Welcome everyone to today's webinar, The Effects of Underwater Noise on the Achievement of Good Environmental Status in UK Waters. I'm Ellie Savage, I'm a Policy Officer at the IES and I'll be hosting the webinar today. So just a quick bit of housekeeping to start us off. This webinar is being recorded and will be uploaded on the IES YouTube channel after the event. For that reason, we won't be sharing slides, but if you're really keen to get your hands on them, I'd suggest contacting one of the speakers directly. Your cameras and microphones should be automatically switched off, but please do feel free to put any comments, or if you're having any technical issues, for instance, please put them in the chat. As always, there'll be a chance for questions at the end of the presentation, so please do submit these in the Q&A option at the top of your screen at any point during the presentation, and I'll ask these on your behalf later. Using the Q&A option means that others can vote on your questions or kind of react or comment to them. So it's really helpful for me as I can see which questions are the most popular. This webinar is being hosted by the Environmental Policy Implementation Community and the Climate Action Community at the IES. I'll pop some links in the chat in a sec, so if you do want to find out more about EPIC or the Climate Action Community, you can do so. But onto the topic at hand. This webinar will explore the findings of a recent project undertaken by ABPmer for the Office of Environmental Protection, which was to review the effects of underwater noise on the achievement of good environmental status. So we're delighted to have three of the experts involved in the project to speak with us today. Andriana Michaeloudis, sorry if I butchered that, Tania, Davey, and Dr. Elena San Martin. So I'm just going to introduce the three of them now, and Andriana will be presenting, and then the three of them will all be taking questions. So Andriana is a marine consultant at ABPmer with over 5 years of experience and a keen interest in marine ecology and underwater noise. Andriana has experience working on a variety of projects, including on environmental assessments, on marine spatial planning, and in supporting the consenting of offshore wind farms. Tania is a principal consultant with over 14 years of experience working in sustainable marine development. She has collaborated on topics such as underwater noise management, spatial planning and prioritization, and conducting plan and project level assessments. Other areas of expertise include undertaking extensive policy and casework for offshore wind development. And finally, Dr. Elena San Martin is a marine ecologist with over 19 years experience in marine environmental consultancy. She specializes in the assessment of underwater noise and vibration on marine fauna and has led technical underwater noise assessments involving acoustic modeling for a range of marine development projects. She's recently completed the underwater noise assessment for the Solent Gateway Marine Project and the Immingham Eastern Ro-Ro Terminal. So welcome again to everyone, and over to you, Andriana.
Cool, thank you. Yes, hopefully you can all see my slides. Delighted to be presenting to you guys today. I'd say thank you to the IES, and this will be an overview of the project that we undertook for the OEP specifically, and then also talking about underwater noise a bit more generally as well. And I've popped the link to the report on the slide, and I think it will also appear in the chat as well for you to have a look at. It's on the OEP's website. So I'll crack on with the presentation. But first, a little bit about who we are at ABPmer as a whole. So we are a wholly owned subsidiary of the Associated British Ports, ABP, and we've been trading since 1950, 75 years now. And ABPmer, so we're made up of over 70 specialists, consultants, covering a range of different projects and themes. So from marine consenting, marine licensing, spatial planning to conducting marine surveys, and also metocean and modelling as well across the company. So that's ABPmer as a whole, and then us three. So yeah, Ellie's already introduced us all, but we're kind of the main project team working on this project. So yeah, myself, Elena and Tania, and a bit of a overview on the presentation. So I'll give some context to the project, why it was commissioned, the approach that we've taken, and then more generally talk about the types of underwater noise and their impacts on marine life. And then part of this project was to assess and kind of predict the future trends in underwater noise across the UK. Think about this in the context of good environmental status, and this is where it gets a bit specific to the project that we undertook. And then off the back of that, thinking about the outcomes and how and what future opportunities there might be to better achieve good environmental status, or faster achieve good environmental status for underwater noise. So I'll crack on. So a bit of context to the project and the OEP. So I think there might be some people from the OEP here attending, but just for those who don't know, the purpose of the OEP Office for Environmental Protection is to hold the government to account for implementing its environmental commitments, and identify any evidence gaps and suggest any regulatory changes that could be implemented to better achieve the environmental commitments that have been set by the government. So this project follows on from a call for evidence that the OEP launched in 2023, and that was to gather evidence on the drivers and the pressures affecting the achievement of good environmental status across the different drivers of GES. So the call for evidence identified underwater noise as a key driver that is an evidence gap and where further action is needed to achieve GES. So this report was commissioned to gather more information to support that and to kind of help address that evidence gap. So GES more generally, so I've got a quote there that defines it, and it is to achieve the UK's shared vision for clean, healthy, safe, productive and biologically diverse seas. And GES is defined under the UK Marine Strategy, and this was previously the Marine Strategy Framework Directive before we left the EU, but that's now defined under the UK Marine Strategy. And underwater noise under good environmental status is defined under descriptor 11. So there are multiple, as 11 different descriptors of underwater noise, and each of them focus on a pressure of the marine environment. So D11 is underwater noise, but you've also got things like control of invasive non-native species, commercial fishing, aspects like that, marine litter. So yeah, this project focuses on underwater noise only. And a bit wider about defining what D11 is. So underwater noise, it's described in two different ways. So we've got two targets on how it can address good environmental status, and they align with the two main properties of sound. So you've got impulsive sounds and continuous sounds, both of these being anthropogenic, so talking about the pressures of sound on the marine environment. So both targets, target 1 and target 2, they both relate to controlling underwater noise of the different sources and different types to a level that doesn't, to make sure that marine life is not adversely affected. So the populations are essentially protected from underwater noise and can sort of be in the marine environment in a safe way in order to achieve GES and that kind of wider biologically diverse ocean. So thinking about the project specifically, the approach we took to undertake this project and understand the evidence gaps was to conduct a literature review. And that was to describe underwater noise in regard to the types of underwater noise there is and impacts to marine life, to understand and gather evidence on how we are progressing towards meeting GES for underwater noise, and then based on that, identifying how we could more quickly achieve GES and what might need to be done to achieve that. So the little diagram and a couple of arrows at the bottom of the screen kind of depicts the process we took. So we gathered information from a range of different sources, including licensing bodies, SNCBs, and international stakeholders, as well as looking at academic research that's out there, really because each different author kind of has a different priority for underwater noise. So we looked at a range of information sources from these range of authors to form that baseline understanding of underwater noise across the UK. And then to supplement this, we used our expert judgment to identify gaps in the knowledge from these sources to predict future trends in underwater noise going forward, and then to also suggest future opportunities, so where more research might be needed or what the government could do to support achieving GES. And altogether, this helped us form a scientifically robust and a highly referenced and up-to-date and balanced report. So talking firstly about the types of underwater noise, the kind of first part of the project. So overall, I mean, many of you are very aware that underwater noise is essential for marine life in many different ways. So it provides a key information source that animals use for communicating, migrating, finding food, those sorts of activities, and ultimately the survival of marine life overall, really. And the image I've shown there is kind of a highly referenced and commonly used photo that depicts different sources of underwater noise, and actually shows that noise is described as a seascape within the marine environment. So there's lots of different types, and they can be described in different ways. And here I've shown that as describing underwater noise by its source, and then also by the sound properties. So I'll dig a little bit deeper into those two categories of noise. So firstly, when you describe underwater noise by the source, we're talking about if it's naturally occurring or if it's anthropogenic, so produced through human activity. So firstly, on naturally occurring sounds, you've got examples of sounds caused by geophysical and meteorological events. These are shown in green on the figure, and they include sources such as wind action over the water, wave action, seismic activity, the movement of tectonic plates, those sorts of things. And then biological sounds, so either naturally produced by marine life, and these are shown in blue on that figure, so include things like communicating and echolocating clicks from marine mammals typically, and also in regard to marine invertebrates, actions like tapping and their feeding appendages can also create underwater noise as well. So they're the kind of key biological types and sources. In regard to anthropogenic sources, these are indicated in orange on the figure, and they include construction in the marine environment. So for example, offshore wind, renewable energy, which is kind of quite important at the moment. It's quite a current topic, something that's expanding rapidly. And in addition to that, you've also got the sound from mineral extraction and dredging and other processes and activities that are kind of essential for maintaining services across the UK. So not just in the marine environment, but actually, dredging, for example, enabling shipping and cargo distribution across the UK. So that's also linked to the vessel movements for things such as the fishing industry as well. And then you've got energy generation. So linked to construction, I suppose, you've got the movement and the sound of generators within the marine environment. So as well as characterising underwater noise by source, you can also do this by the sound properties, and the two main properties of sounds are can be categorised as either impulsive or continuous. So Impulsive sounds are typically very high frequency, they're very loud, but they are very short lasting, so they last seconds to milliseconds. And examples include percussive piling, seismic surveys, so for example the use of air guns in geophysical surveys. And you've also got use of explosives, so for example in detonation of UXO, unexploded ordnance. In regard to continuous noise, by continuous noise, we're talking about longer lasting underwater noise, and it's typically at a lower frequency. So examples of this include from vessel movements, so the sound from propellers and generators, and also the generation of renewable and unrenewable energy within the marine environment, so the sound of generators themselves working. And I've also put at the bottom ambient as a definition of underwater noise, and this is because it's a commonly used definition of sound to describe background sound essentially in the marine environment. So it's a mix of impulsive and continuous and natural and anthropogenic sounds to collectively make up that background underwater noise level, so including things like waves and shipping and also biological sounds. So this was kind of the baseline understanding that we formed, from which we could then look into the impacts of these different types of sounds on marine life. So I've been thinking about the impacts of underwater noise. We firstly wanted to identify the key marine species that would be impacted by underwater noise, and these are those four diagrams and little images at the top. So we looked at marine mammals, at fish, benthic invertebrates, and diving birds, because they all have the potential to be affected by underwater noise because they cannot perceive underwater noise. And it also, interestingly, linked to GES and that kind of common theme of the project was that these four species or animal groups fall under the UK Marine Strategy Descriptor 1 and Descriptor 4. So that kind of all ties in quite well. And when I say that these species have the potential to be affected by underwater noise, you can see below it's because they can all perceive underwater noise, so they can all hear it, and but to different extents. So you've got the hearing ranges right at the bottom of key marine species, and then you've got the range of frequencies that anthropogenic sounds, so for example from shipping or from oil extraction, at the top. And you can see that baleen whales and fish and typically larger deep diving species have a very wide hearing range, typically at the lower frequencies, whereas species such as seals and dolphins can hear at that medium range, but also very high frequency as well. And the fact that all of these kind of overlap to some extent with the anthropogenic activities means, again, that they will be impacted to varying levels by sound. And when we thought closer about the different impacts, we then categorise these as is done in many different sort of well-referenced literature, by either physiological impacts or behavioural impacts. And these both occur due to a stress response to underwater noise. So when we talk about physiological impacts, we talk about physical damage to hearing organs of the species, whereas behavioural impacts relates more to changes in the movement as a result of being exposed to the underwater noise. But there are some key considerations that we need to consider when thinking about the impacts of underwater noise, particularly in the context of GES. And it's important to consider population level impacts, not just to the individual. And that's because before, as we talked about, target 1 and target 2 of GES was to make sure that underwater noise doesn't adversely affect species at the population level, not just individuals. So when we had a look a little bit deeper, specific impacts that we found of the different receptors that we sort of scoped into this report listed above. They included both physiological and behavioural impacts, such as threshold shift, changes in avoidance and displacement, the movement changes from marine mammals, specifically strandings, and also disruption to kind of normal predator-prey interactions as well. So the table highlights what impacts different receptors experience, and mostly you can kind of see that marine mammals and fish are impacted the most by underwater noise. And one of the first two impacts, which are specific to species with hearing organs, is threshold shift. So this can either be permanent damage or temporary damage to the hearing organs. So that impact is specific to underwater noise, and in marine mammals and fish. So we also found in the evidence that we gathered that there's seemed to be fewer impacts of underwater noise to marine benthic invertebrates and diving birds. But importantly, there's actually significantly less information and evidence available. So that should be kind of considered in that there are not no effects. There's just significantly fewer examples of where this has been documented. So there's a potential evidence gap, really. And then again, kind of just at the bottom, the population level impacts within all of these different receptors is an evidence gap, as well as a marine species kind of as a whole, all the different receptors collectively. So I'll move on to the future trends in underwater noise. So we used the evidence and the engagement we had with different stakeholders and the different authors to understand future trends of underwater noise across the UK, both sector-specific trends and then also more kind of high-level strategic trends. So sector-specific trends, first of all, in regard to each sector and collectively, there's no doubt that underwater noise will increase in the marine environment going forward. The seas are becoming much busier, and there's absolutely no doubt that underwater noise will increase. How it will increase and what form is very uncertain, and it's due to lots of different drivers impacting each of the different sectors. But mainly, this is likely to be driven by the expansion of the renewable energy industry in the marine environment, increased shipping activity across the UK, but also internationally, and also the need to maintain the operation of essential services, so things like shipping, but also aggregate extraction and commercial fishing. And I've highlighted the increased development of offshore renewable energy in orange there as a kind of a key, quite current and sector that's been and a lot of research being done at the moment, really, because it's so current and because of the increased development that's likely to happen will happen in the next decade or so. But specific to underwater noise from offshore wind, key and specific examples where underwater noise could be produced and will be is the use of unexploded, so UXO, unexploded ordnance detonation, and that can be at the design stage, essentially, before offshore wind farms can be designed. They need to know where to put them, as to make sure that the development's in a safe place away from UXOs, which then links to the seismic surveys, which need to be conducted kind of in tandem with that. You've got construction of offshore wind farms themselves, so the piling of the towers and the foundations into the seabed, and then also the operation and maintenance that's required for development. So that is most linked to vessel movements and movement of ships, providing crew or replacement parts to the wind farms. And it also should be noted actually that in the future, floating offshore wind is going to be developed at increasing rate than fixed potentially, and that brings with it different sources of underwater noise. So this sector is rapidly changing. So underwater noise, it's less certain, but there'll be a lot more change in the future on what the underwater noise sources might be. For example, with floating offshore wind, you might get more sounds attributed to the kind of snagging of mooring lines, those sorts of things. But in addition, you've got shown here sort of commercial fishing industry, where you'll get underwater noise produced from, military activity as well, which is a sector where there's quite high uncertainty of due to the need to protect national security. The exact types of underwater noise produced by the sector is unknown, although it is likely to include seismic surveys and use of explosives in training exercises. And similarly, the oil and gas industry is also quite uncertain what the noise levels will be from this industry, because overall there is a decline in the sector, but actually the activities in the sector producing noise might change, because there'll likely be an increase in decommissioning of rigs, and also repurposing of them for different sectors. So, for example, to support carbon capture sector and hydrogen sector. So whether there's going to be an overall increase or decrease is kind of uncertain for that sector, but that's quite an interesting one to look at. So moving on from sector-specific trends, it's also looking at the strategic level. Underwater noise in the future can be understood by thinking about what strategies are in place and how they can inform what sounds will be produced in the future. So I've got some examples here of the key strategic policies and aspects that we found. So setting of thresholds. This includes in the harbour porpoise SACs, so thresholds have been set already, and this can indicate that sound will be managed so that sound does not exceed the levels of the thresholds. So that can kind of indicate in the future, if further thresholds are set in different regions, how underwater noise might be managed within that region, and then how that is scaled up to the UK. You then got strategic monitoring. So increasing monitoring at the strategic level can also improve understanding of underwater noise, and then therefore kind of inform how it is managed going forward. You've got policy papers and licence conditions. So they prescribe what mitigation needs to be put in place. So again, how underwater noise is managed in certain scenarios. At the top right, we've got the the Marine Noise Registry, and that is developed by JNCC, and that shows at the strategic level what underwater noise, the levels of underwater noise that might occur in the future. So it documents impulsive noise sources and categorises them by type and by intensity, and it's an online resource, and you can download the data. Each year it's published both in reports and in the GIS files, so you can kind of understand what underwater noise is currently produced, and also it does have a look ahead as well into what will be produced in the future. So looking at this strategic source of information can also kind of indicate what underwater noise is looking like going ahead. Although I will say it's probably quite underused at the moment, and it's a resource that will it's one of the targets of underwater noise for GES, and it will be kind of continue to be developed in the future. So it is one to probably use going forward. There will be lots of change and kind of increased functionality of the registry. Then it's important finally to consider transboundary effects when thinking about future underwater noise at the strategic level, because as species in the UK, for example, marine mammals are really highly mobile, underwater noise produced outside the UK will impact these species using UK waters. So that's quite key to consider when thinking about noise in the future. And so progress towards achieving GES. Progress has been made. Great progress has been made so far in a number of different ways. So from part 1 of the UK Marine Strategy being published in 2012 to part 3 most recently being published in 2025. The current status and kind of progress of underwater noise is that so far it's been partially achieved and that it's been stable since 2012. So again, I've just kind of recapped the 2 targets of underwater noise, and thinking a little bit deeper about what that means for GES. To achieve those targets, 2 indicators were set, 1 for each of the targets. So you've got indicator 1, which is to establish that noise registry. As I said, it contains information on impulsive sounds. So that's how that links to target 1 being managing impulsive sound to levels that don't adversely affect populations. And then the second indicator relates to target 2, and it's a surveillance indicator. So it's to monitor ambient and continuous noise levels. And that's because so far there's a lot less evidence on the impacts of continuous noise on marine mammals and, well, marine species generally in the marine environment. So it's important to have a surveillance indicator before quantitative thresholds can then be set. So how we've been doing so far, we've developed the noise marine registry that's in use and is being used at the moment by different developers when they need to submit information on the noise that has been produced by certain developments. But a question that still remains and is a kind of potential barrier to achieving GES so far is that understanding of population level effects. So there is less information on this and is an evidence gap really that is needed to be answered before it can be GES can be fully achieved. So the kind of diagram on the right just shows the progress that has been made since part 1 was published in 2012. And thinking about that in kind of a wider context of environmental status as a whole, the progress that has been made should be viewed as qualitative only. It doesn't directly relate to a quantified reduction in underwater noise. For GES is to manage it to a level that doesn't adversely affect populations rather than achieve a specific reduction in sound. And I've got here a few more examples of the progress that has been made so far. So you've got the noise registry right at the top. There's a link to it on JNCC's website, so you can have a look at previous years' data and then also looking ahead as well. The UK, so we're a signatory of the OSPAR Convention, and actually strategy, so objective 8 of a strategy relates to underwater noise, and it aligns very closely with GES, so kind of shows how the UK are helping to manage noise in a consistent way outside of the UK. And lots of monitoring has been undertaken specifically to address indicator number 2, which was that surveillance indicator of ambient noise. So we've got a few examples there of projects that have happened in the North Sea, in the Atlantic Sea, and in Scotland as well, that have been helping to monitor the level of ambient noise, which can then help quantitative thresholds be set for ambient noise. That's kind of the aim really, or how GES will be adapted, and the definition of it will be changed in the future. And then finally, that kind of fourth bullet point is quite recent. So in 2025, in January 2025, government released the UXO position, joint position statement, which is quite a step forward, and it's quite timely with the development of offshore wind at the moment. So so the position statement was that low order methods of UXO detonation should be the default, rather than using high order methods, which are more noisy. They create a lot more underwater noise, and it's shown to have effects such as like displacement on marine species. So for low order methods being the default, that's quite a key policy really to manage underwater noise, specifically for the offshore wind industry. So thinking about the challenges and barriers, once you've considered the progress that has been made, there's a high kind of uncertainty on the scale of projected increased noise in the future, which does make setting thresholds and forming a policy challenging. So that's a kind of a key challenge to progressing towards achieving GES. And in addition, there's a lack of kind of cohesive understanding of underwater noise management across the UK. So that's a barrier to achieving GES, again, because GES covers the entirety of the UK. And a challenge that we've noticed that could be addressed to help better achieve GES is to kind of increase the amount of incentives really to encourage GES to be achieved specifically through developing noise abatement systems. I'll move on now to the kind of, off the back of that, the future recommendations that we have suggested. So to address that kind of lack of UK-wide strategy specifically targeted to underwater noise, we've kind of proposed this sort of diagram on the right-hand side, which is a potential kind of suggestion of how this could be done going into the future. So across the UK, it would be important to achieve GES, and to do this through underwater noise would be to use existing mechanisms that are in place and feedback loops between them to really kind of share understanding and learnings of underwater noise, so that can feed back into and creating those definitions in the first place. So that would include aspects such as the use of marine protected areas, licence conditions, the marine noise registry, activities that are already in place, but having kind of feedback loops between them to maximise kind of the use of them and the benefit that will be gained, and to make sure that this is not only shared across the UK but internationally as well. Again, thinking about that kind of transboundary aspect towards underwater noise and the need to manage that. And some other examples as well, we've got continued development of the marine noise registry. That is happening year on year, but a suggestion would be specifically to focus on addressing the cumulative effects as well, as that's kind of key as the marine environment becomes busier. So ensuring that it can kind of capture that those trends, and then improving evidence as well, particularly regarding those population level impacts, which is the kind of key evidence gap really that is directly linked to achieving GES. So making sure that understanding that we gain through, for example, using a UK-wide management strategy or through increased research, all ties back in to understanding those population level effects. And then another aspect of the project was specifically to look at innovative technologies, and that's something that's key for the UK government. And actually this quote from Coastal Futures this year was that the government is committed to minimising the impacts of underwater noise and accelerate offshore wind generation. and it will specifically do this by developing innovative technologies, and they will be championed. So that kind of states quite clearly that developing innovative noise abatement techniques is key to managing underwater noise in the future. And I put some photos and some diagrams of techniques that are in existence already and that are being developed that can help to do this. So, for example, bubble curtains, that involves placing a hose at the bottom of a pile, shooting bubbles into the water column, and essentially the noise levels outside of those bubbles are significantly less than within. That kind of same approach has been taken when developing encapsulating systems. So that just uses a physical structure to encase piles and reduce the amount of underwater noise during piling. Again, related to piling are the alternative techniques that can be used. So both the activities and the process of getting the piles into the seabed, so the use of vibro piling instead of kind of traditional impulsive techniques, and also more recently changes in the hammer design has also been developed. So for example, using water-filled hammers as opposed to steel, that's also been shown to reduce the amount of underwater noise as the water in the hammer absorbs some of that noise. And then in constant kind of development are modifications to vessels. So either making them, well, traditionally and kind of most importantly, making them most streamlined so that they produce less underwater noise when they're moving through the water column, and also the adaptation of propellers as well on the vessels will also help to do this. So that's it from for this presentation. Apart from a couple of conclusions, which we've kind of talked about at the moment, kind of throughout, which is the key types of underwater noise, future trends in underwater noise, and essentially the progress that needs to be made to better achieve and faster achieve underwater noise, which we can see in those few arrows there. But that's it from me. So yeah, I'll say a big thank you. And yeah, I'll see if any of you have any questions. I'll stop sharing my screen now so I can see everyone.
Amazing. Thank you, Andriana. That was really, really clear. I thought really engaging. So thank you so much. We are a bit over time, but I didn't want to stop you because I thought it was all
yeah,
very
apologies for that.
interesting. No, it's okay. So yeah, just to our attendees, we might go, 5 minutes over time for the scheduled webinar. Obviously, understand if you need to leave, but hopefully you can still stick around. Great. Well, I'm just going to take the chair's prerogative first and ask, I guess it's an easy question. I actually got asked this 2 days ago when I was presenting on a report that I'd done, and I actually thought it was quite useful. But what surprised you the most in putting together this report? Was there anything that you really weren't expecting during the process of putting it together?
Yeah, I thought so kind of in doing the research during the report, it was kind of clear really that there's a lot of more understanding of impulsive noise compared to continuous noise, and actually that stuck out as a key evidence gap, and it sort of surprised me in the level of kind of difference in understanding that there was, and that's essentially led to the fact that a quantified sort of specific target can be set for impulsive noise, whereas it can't for continuous noise because the level of understanding just isn't there yet.
It's just hampering the action because we just don't have the evidence. And Elena and Tania, do you kind of agree with that, or is there something else that you found even more surprising?
For me, one of the really positive things is to appreciate the amount of work that is happening internationally, but then to to identify the need for international collaboration and sharing of knowledge so that we're not reinventing the wheel, I think is really important. So that was a really positive output, and we captured a lot of that international experience in the report as well.
Yeah, and building on Tania's response as well, I think it's the fact that it's it should be a UK wide, because obviously I think, I can understand the importance of devolved administrations having different approaches, but having some sort of UK wide strategic approach to dealing with underwater noise and the issues, I think that's kind of fundamental within the context of the wider international community as well. Yeah. So
great. Thanks both. Well, I'm going to go to some questions from the Q&A tab. So Dennis Thompson asks, from a protection/mitigation strategy approach, are wildlife corridors feasible or being considered here, and what role could marine protected areas play? Because I did notice at the end there, I think Dennis had submitted his question before you had this on the slides. Andriana, you did talk about maximising the role of MPAs as one of the recommendations, but how would that work? Maybe if there's any more detail on that. Thanks.
Yeah, I think at the moment there doesn't look to be specific kind of information on how underwater noise within MPAs is managed. I think within SACs there are thresholds, and that's evident in the harbour porpoise SACs. So that's one way that's been done already. But I think looking at existing MPAs and how we can understand and manage underwater noise within them would be a step forward, rather than kind of forming new ways of protecting, or for example, like new marine protected areas. I think focus on the ones that we've already got would probably be the first step. In terms of wildlife corridors, I'm not aware of how that's been addressed in the context of underwater noise so far, but I think strategic planning is on the agenda and should be kind of considered within sort of management. If that answers.
Yeah, no, thanks, Adriana. Elena or Tania, do you have anything to add on that? Or
just thinking off the top of my head, I think in terms of wildlife corridors, I think it's a good idea. I think it would be quite challenging with underwater noise because of the overlapping nature of it, the cumulative different activities and projects that might be taking place, and to understand whether you can have those corridors available which have a reduced underwater noise, I assume, to be able to allow the movement of or at least unrestricted areas. I like the idea. I'm just not sure how it would could be implemented in practice. In terms of MPAs, the ones that are already designated, any licensable activity will have to already consider what their potential impacts are on those MPAs. And obviously, if they're protected, barring what we just spoke about the SACs for harbour porpoise, but if they are protecting, whether it's migratory fish or other mobile features that are sensitive to underwater noise, seals, they will need to consider those effects and ensure they're not adversely affecting those features. So in some ways they are already playing a role, an important role. Whether there could be implementation of more management measures through those protected areas, that's a possibility. I know up in Scotland they've had fisheries management measures to I guess protect those areas from commercial fishing activity, but that was more in relation to benthic habitats, protection of those. So yeah, it's possibly an opportunity there to do something more. Yeah.
great. Okay, I'll move on to the next question then, unless Tanya, you have anything burning to add.
No, you go ahead.
Okay, so Phil asks, well, we've been working in offshore wind in Asia. We see acceptable noise levels being quoted around, oh gosh, see, I'm not technical here, 180 dB, RE1, all UPA. I mean, I might have to just post that in the chat because I'm struggling here. But I guess it's
Decibels
not
reference to 1 micropascal. There you go.
Wow, there
Don't
we go.
worry.
This is me being outed as, I'm not even actually an environmental scientist. But yeah, okay, I've put it in the chat, but let's get back to the Q&A tab. At say 1.5 kilometer from piling as a monitoring criteria, that has always seemed very high, but the advice we've received is that it is consistent with international standards. And his question is, are there any clear quantitative standards we can refer developers / consultants to when preparing impact assessments and monitoring plans at a project level? Anybody want to take that one?
Should I let you jump in, Elena?
Well, I'll do it
Tricky
more
one.
from a UK level because I haven't worked on any international underwater noise assessments, but UK level, we would assess the propagation of the noise. So you'd have your unweighted, sorry, this might get a bit techie, but yeah, unweighted noise levels from the source of noise. And then you'd apply published thresholds, any published thresholds available on whether that's injury or behavioural thresholds on different marine fauna. So there's NOAA, just updated their thresholds for marine mammals. There's Popper et al. That have thresholds for fish and fish eggs as well, or different groups of fish with different hearing kind of categories. So that's the way we'd apply. There's no, at the moment, no level being proposed by, say, UK government or advisors on what is acceptable as a like they've done in Germany. But I haven't worked in Germany, so I don't know the details to be able to sort of give you that information just now. But yeah, I don't know if that answers the question, but hopefully it helps a little bit. I don't know if anyone else has anything else to add.
Yeah, just to add, yeah, exactly. We don't have a noise threshold in UK waters, but there is a study ongoing funded by the Crown Estate, their offshore wind evidence and change programme, which is looking at mitigation for offshore wind. And one of those projects is to consider noise limits. So we don't have anything, but there is ongoing research to understand what a noise limit could be, how beneficial it would be as well.
And do you think, obviously you say there's studies ongoing to look at the kind of feasibility and those things, but from your professional opinions, do you think that that could be a useful policy to have a noise threshold for underwater noise?
Yes, in the sense it could give some clarity, but as long as it's, I guess it's depending on how limiting it is, and as long as it's having a proper ecological kind of benefit, yeah. But yeah, you have to kind of weigh those trade-offs, the ecological benefit versus, the development that needs to also go ahead, perhaps in many cases, yeah.
Okay, and then I'll just ask one more question to finish us off. And yes, it's a bit of a classic. Obviously, you had your kind of recommendations at the end there of your report. And if you could pick kind of one priority key recommendation, if you're like, if I pick this, it happens. I don't have to worry about anyone listening to me. It definitely is going to happen. If you could pick one for action on underwater noise, what would it be? Maybe we'll start with Tania first.
I think the one that stands out for me is a sort of holistic programme of underwater noise management in the UK. There is a lot going on, and especially in the past 5 years, there's been a huge increase, especially in the body of research and evidence, which is really quite impressive once you delve into it. But there's been a big programme to try and better understand ambient noise. There's been a lot of work to understand impulsive noise from an offshore wind perspective, but there's nothing at the minute combining it together. And the UK Marine Strategy and Good Environmental Status, which is what this report is based upon, is a good umbrella to have that more holistic programme of underwater noise management.
Great. And Adriana, maybe we'll go to you next.
Yeah, I couldn't agree more. I think that kind of overarching strategic level approach to management, I think is the way where it needs to go, even in looking at like vocational specific thresholds. I think learning from that and seeing where that could be applied elsewhere, or like considering the kind of highly mobile nature of species. I think that kind of shows as well that we need kind of that holistic approach.
Yeah, and that's kind of working across government departments as well, which is obviously notoriously difficult, doesn't get done. And also I guess bringing it to kind of like the IES. We've got members working in all areas of environmental science, and it's that kind of making sure that we have the marine scientists talking to the climatologists and people working in renewable energy, and also to like terrestrial ecologists. And we would agree with you there. And Elena, what about you? What would be your kind of one
Sorry, I'm
priority
nodding vigorously,
recommendation?
but yes, completely. I mean, certainly, yeah, that I think is perhaps ambitious, but I think that's where you're going to get the most out of it. You know, it's through a holistic approach. I'm always found that with underwater noise, we may be able to sort of potentially understand or predict the effects on, you know, perhaps an individual species or group of species, but it's the population level consequences as well that are a key gap and uncertainty, and that's still, I think, a big challenge in underwater noise.
Yeah.
So
that did really stand out to me, the fact that that was kind of missing as an evidence gap, because obviously that's really key in understanding the impacts, and in terms of thinking about like risks and tipping points is really key. So it's almost like I guess at the moment it's just like people don't have to necessarily worry about it, because it's
still in the too difficult box, I think.
But it's like, what happens when we open the box? What's going to be in there?
No, as long as
anyway,
we're aware of it, I think, and we try to move a bit forward each time. Yeah, that's what we've got to do. Okay.
Great. Well, that's good, because I was going to end us on a horrible scary point, but you've kind of made it a little bit less scary. So thank you. Well, thank you so much. Exactly. Thank you so much, everyone, for attending. Obviously, thank you so much to all of our speakers. As I said at the start, this has been recorded and it will be put on the IES YouTube channel in the coming days. But yeah, that's it really. Sorry we ran over time a little bit. But yeah, I hope you enjoyed the presentation, and have a great rest of your day, everyone.